Okay, guys, today we are solving trig equations. This is why we care about simplifying trig expressions as we did in our last lesson, so that way we can solve equations. We have to go through the process of simplifying first before we can solve. So let's take a look at this equation here in green. It says solve 2x plus 1 equals 0. And hopefully we could all do this, subtract 1 both sides, divide by 2 both sides, we get x equals. You are correct. X equals negative 1/2. Now this is fairly simple. And when I look at this equation, notice that basically the only thing that's replaced is x with sine of x. So how would I solve this? Well, if I solve for sine of x, I would get that sine of x is negative 1/2. This looks similar. But, we're solving for x, not sine of x. So hopefully we remember, we would take the inverse of both sides. So I get x equals inverse sine of negative 1/2. And I think about, okay, my domain, my range. I also think about my unit circle. And I know that I'd have two solutions here. I'd have 7 pi over 6 and 11 pi over 6. Okay, this comes from what we did last unit. Now notice that the directions said here solve in the restricted domain from 0 to 2 pi, not including 2 pi. And both of these solutions are between 0 and 2 pi. But if you think about this, if I think about on the unit circle, which can continue forever and ever, where's the sign? Negative 1/2. Technically, if I didn't have this here, this restricted domain, technically I could have an infinite amount of solutions. So look at these directions. It says solve. Well, I'm going to get to the same step, right? I'm going to get to the step of where I have x equals inverse sine of negative 1/2. But my solutions can be from any number. So I got to think about my coterminal angles for these two solutions. So I could get x equals 7 pi over 6. And to represent all of its coterminal angles, I'm going to have 2 pi, and then however many times we want to go around, 2 pi n. So this represents all of the coterminal angles of 7 pi 6. And don't forget, we also had 11 pi 6, which is a different spot on the unit circle, but I want all of its coterminal angles as well. Okay, so we're going to go through a series of questions here where we're asked to solve a trig equation under a restricted domain, but then also we want to provide the general solutions. So what I'd like you to do right now is explain the process for solving a trig equation in words. So go ahead, put me on pause, write that down, and then let's try some more problems. Okay, so moving on here, I'm going to have you guys try to solve this. At least part A, I think you should be able to do. It says solve part A under the domain from 0 to 2 pi. And my hint for you is that you should have 4 answers for part A. And then for part B, your general solutions, technically you'll have 2 answers. I mean, really they're infinite amount, but 2 general answers, okay? So go ahead, solve this. At minimum, you can solve for x. I really think you guys can do part A. Part B, I think you should try. All right, so go ahead and put me on pause. Okay, so let's check our answers here. So when you solve, you get cotangent of x equals plus or minus. That's critical that you have both positive and negative. Plus or minus square root of 1/3, which, by the way, I don't have it written here, but this is the same thing as 1 over square root of 3. That might be helpful for some of you, which is the same thing as plus or minus square root of 3 over 3. So I look at my unit circle and I think about, okay, well, where's the cotangent positive root 3 over 3? And where's the cotangent negative root 3 over 3? Which is why I gave you the hint that this is going to have 4 solutions. So here are my 4 solutions. Okay, I think about, where do I get positive root 3 over 3? Well, that would be at pi thirds and also 4 pi thirds, right? Here and here. And then for negative root 3 over 3, I would get that at 2 pi thirds and also 5 pi thirds. So that's for part A. That's between 0 and 2 pi. But I also want to know my general solutions, because we know that we could have coterminal angles for all 4 of these. So if I think about this, my hint was that you should really only have 2. My hint hopefully got you to here. So at pi thirds, although I could do, my coterminal angle, it's also pi n away, right? So at pi thirds, I'd add pi, add another pi, add another pi. So that does cover pi thirds and the 4 pi thirds. At 2 pi thirds, same thing. I could do its coterminal angle, but also it's pi units away. So at 2 pi thirds, 5 pi thirds, and then I keep going around for my general solutions. Okay. All right, let's have you guys try this one on your own. Go ahead. Okay, so I solve this. I get secant of x is plus or minus 1. So make sure you're thinking about, okay, well, where is the secant? Positive 1 and negative 1. And that occurs at 0 and at pi, right? Here the secant is positive 1. Here the secant is negative 1. And then for my general solutions, so remember, if I think about this graph, it could occur here or it could occur here. So I could just say 0 plus pi n, right? Keep adding pi around. You also could have just said this as pi n, because 0 plus pi n is just pi n. All right, let's have you guys try this one. Now, this one's different because you have 2 trig functions in the equation other than 1. So my advice to you is to get a single trig function first. So maybe this will kind of remind you what we did in our previous unit when we were simplifying. So get a single trig function first, and then let's solve, and then come up with the solutions. So let's see what you can do. Go ahead, put me on pause, and try this one. Okay, so hopefully you got 4 solutions between 0 and 2 pi. So pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. And then for our general solutions here, I know, if pi thirds is one of my solutions, and this is tangent of x, then I know that 4 pi thirds is also a solution. So really it's pi thirds plus pi n. Keep going pi around. Same thing for 2 pi thirds plus pi n. If you're wondering how I got tangent of x, remember my advice to you is to get one single trig function first. So I divided both sides by cosine squared of x and got tangent squared of x, and then solve from there. All right, let's have you guys try this one. Once again, do your best to come up with one single trig function. That would be helpful if you can. All right, go ahead, put me on pause. All right, so part of this is, putting this in terms of cosine. Right away in step 1, I changed the sine squared of x to 1 minus cosine squared of x. I'm using that Pythagorean identity. From there, I'm bringing everything to one side, and I factor out a GCF of cosine of x. So then, actually, this really should be a negative 1 still. But anyway, so I factor out GCF of cosine of x. I set that equal to 0. I also set this equal to 0, which will give me cosine of x equals negative 1/2. So I have 2 cases here. I found their solutions between 0 and 2 pi. Cosine of x is 0 at pi halves and 3 pi halves. Cosine of x is negative 1/2 at 2 pi thirds and 4 pi thirds. All right, and then, sorry, I meant to put a 2 pi in there. For our general solutions here, I know that these are just pi units away, so I have pi halves plus pi n. For these two guys, those would be in our second and third quadrant. So I'm going to have 2 pi thirds plus 2 pi n, and then 4 pi thirds plus 2 pi n as well. All right. All right, next example. Let's have you guys try this one on your own again. Go ahead, put me on pause. All right, the key to this example was being able to factor in this first step. Notice that I do have a quadratic here. That's 2 sine of x plus 1 times sine of x plus 1. Using the zero product property, I'm going to set each of these factors equal to 0, and I get sine of x is negative 1/2. and sine of x is -1. So for sine of x is -1/2, that occurs at 7 pi 6 and 11 pi 6. For sine of x being -1, that just occurs at 3 pi halves. And then finally, my three general solutions. What the heck? Okay, this is a joke, right? This is a mean joke. Please stay. Okay, 7 pi 6, I'm going to go a full revolution around, so that's plus 2 pi n. Same thing with 11 pi 6, and same thing with 3 pi halves. Final example. All right, so let's have you guys try this one. Again, I would do some simplification here. That's a big word. Simplification. Maybe try to simplify. I have cosine, sine, and tangent. So let's see what you guys can do. Okay, go ahead, put me on pause. Okay, so were you struggling to solve for one trig function? Yeah, okay. Well, let's help you out. So start by making tangent of x sine of x over cosine of x. And to get rid of this cosine of x in the denominator, let's multiply both sides by cosine of x. When I do that, don't forget to distribute. I get cosine squared of x plus sine squared of x, which is 1, equals 2 cosine of x. So now I have cosine of x is 1/2. Now, don't be cheaters. Now that you were able to get that, now let's answer part A and B. So put me on pause again, and then we'll check your actual solutions. Don't be that person. Okay, so here are my solutions for cosine of x being 1/2. I know that it occurs at pi thirds and 5 pi thirds. My general solutions, I want to go one revolution from each of these, so actually an infinite amount of revolutions. So that's pi thirds plus 2 pi n and 5 pi thirds plus 2 pi n. All right, so just some strategies. Isolate the trig functions on one side of the equation. You know, we want to use algebra. We could factor. You might see multiplying both sides. You might have to combine like terms. You could see almost anything. It's crazy. All right, and make sure that we use our trig identities to convert to one type of trig function. All right, great job today, and I'll see you in class.